Welcome to this section on learning the basics of C#. Once you learn the basics of C#, you are going to have smooth sailing through C# courses and indeed any other object-oriented language. The only thing that changes between, say, C#, Java, or JavaScript is the language itself. The themes and the concepts that I'm going to teach you here are applicable to almost every object-oriented language you can think of. In this section, you'll learn about things such as variables. These are the basic building blocks that hold data inside programs. You'll learn about operators that we can use to add or subtract, for example, some of those variables. You'll learn how to convert between different variable types, when you should and when you shouldn't. You'll learn how to compare variables. Do two numbers actually equal each other? You'll discover all about loops, which are instructions that run round and round until a certain instruction has been met. Then we'll look at arrays, which are lists of data. We'll look at methods, which are ways of dealing with data such as variables or arrays. We'll look at classes, which are one of the fundamental building blocks of all object-oriented languages. We'll look at class inheritance, which is another cornerstone of most OOP languages. And finally, we'll look at exceptions, which is a fancy way of saying errors when your code does something that it doesn't expect. We'll learn how to handle them so you don't experience a crash in any of your apps. So let's get started. Let's begin by looking at variables in C#. A variable is the smallest practical working block for most applications that you will construct. This isn't technically true, but practically speaking, it will be. Now, as this is the first lesson in this little mini series, we have to set up our development environment. We could go about setting up Visual Studio or MonoDevelop or a similar environment, but these days, as we're in 2016, people have already set up websites that allow us to develop in C# and evaluate that development. And one of my favorites that we're going to use throughout this section on learning C# is to be found at www.csharppad.com. So head over there now and let's begin learning about variables in C#. As I said previously, a variable is a container that holds a little bit of data. Now in C#, variables have what's called a type. So they're containers that can only hold certain kinds of data. The very first one we're going to look at is called an integer. And this is defined in C# generally by typing int. There are different kinds of integers, such as an int 16 or an int 32. But for most purposes, simply defining int will do the trick. Then a variable needs a name, because variables are there for us to use later on and reference, and a name is the correct way to do this. Now you should never name a variable after its type, so you should never call this int, because C# and .NET will get very confused and your program won't compile. So you have to give it a name. Let's call this Grant age. And you'll notice I've placed the first letter in lowercase and I've placed the first letter of the second word in uppercase. And this is called camel casing. It is a common convention in C#. Don't worry, you'll pick this up as we go along. Now, we have to make that integer equal to something. So we simply type equals, and this is called an assignment operator. It's going to make whatever we put on the right-hand side, and it's going to grab it and store it inside the integer called grant age. And because we've said explicitly this is an integer, we can only store whole numbers in it, because that's what an integer is in the programming world. So my age is 33, if I remember correctly. And then we put a semicolon after that declaration to tell C# we're ending this line where we are. So now we have an integer called grant age stored as 33. Of course, we can have other types of variables. What if we have a more complicated number? Well, we can have something called a float. And we can have grant age in months is equal to whatever 33 times 12 is. I'll probably get this wrong. Something like 360.87. And floats allow us to have a decimal point, but we have to put an F at the end of the number to indicate that it is a float. We can also have numbers called doubles, and this could be age in years is equal to 33.45, and you don't need to append that with anything, so that will store some decimals for you. We can have another kind of variable called a Boolean, and we define this with bool, and I'm going to call this true or false. And a Boolean can only contain one of two values, either true or false, and we define it as true or as false. And these variables, Booleans, help us keep track of things that are switched on or off inside of our program, so they're very handy. Right, we have one more variable that I'm going to show you in this section, and this variable is something that holds letters and characters, and it is called a string. So I'm going to call this my sentence is equal to, and the way we define a string is by enclosing it in double quotes. So my name is Grant, and close your double quotes. So this stores a bunch of characters for us that we could possibly want to display to a user as a message. So in effect, think of strings as items that hold human readable words or numbers. Okay, what if I wanted to change one of these items that I've already defined? Well, I could say grant age, and C# references that integer that I first declared, and I can make it equal to 34 instead of 33. So now that grant age box holds a different value. It's no longer 33, that's been overwritten, and now it holds 34. In C#, there's no way to go back in time and undo this. So if you're completely new to programming, you can't simply say undo that operation and give me the old value, because the old value is gone. Now, what if I wanted to change grant age to a string? Grant age is equal to 34. Let's see what C#pad has to say about this. I've got a little triangle on the left, and it says cannot implicitly convert type string to int. What this means is that if you have a container that you've explicitly said stores an integer, you can't then go and put a different type of item in it. So you can't put a string in it, you can't put a boolean, no floats and no doubles. It can only hold integers. So never try to mix your variables. Now, what if my name is Grant never changes as a sentence? Well, in C#, if someone else came along on my programming team and said my sentence is equal to name is Fred, they would change the value of my sentence. And if I don't want them to do that, because I realize that I want this sentence to be always the same, what I can do is put a keyword in front of string my sentence called const. That stands for constant. And I'm telling C# and .NET this thing can never change once I've set it. That's why we're now getting our warning triangle that says the left-hand side of an assignment, and let me just expand this window, must be a variable, property, or indexer. It's basically saying, in really complicated language, that, hey dude, you defined a constant earlier and now you're trying to change it, and I can't do that. So it will give you an error. And this kind of thing ensures that other programmers don't change the strings or the variables that you want to keep constant. Okay, that's all there is really to variables in C#. If you want to know more, then simply jump onto Google and look up variables. But this is all you really need to know at this point. Just grasp the concept that a variable is a container that stores a value of a certain type. Let's learn all about operators in C#. Operators are just as you imagine. They're the plus, minuses, multiply, and divides of this world. We're going to use them on some variables. And now that you already know how to define a variable, this lesson should be pretty easy. Go ahead and open up csharppad.com and let's begin. Start by defining two integers. Let's have int my num is equal to 9. Let's have another int other num is equal to 12. Now let's look at operators. Let's say integer result is equal to my num plus other num. And what this does is grab my num and add other num to it and provide us with an integer result at the end. How do we know this has worked? Well, in C# we can send ourselves a little message by using console.writeLine, and then we can pass it over the item we want to output to our user. So let's try result and close brackets. Now this should write out the result to our console. And how do we access this in C#pad? Well, we simply click this Go button at the bottom right. When I click Go, it's going to add those numbers for me and print out this result, 21. Of course, we can do the same calculation by copying that code, repasting it in. We can do, let's try a multiply, which is the asterisk character. Let's click Go, and our result is now 108. Let's paste that in again and try to divide. So 9 divided by 12. We would expect 0.75 to come out of this. But we get 0. Now, why is that? It's because an integer can only store a whole number. It cannot store decimals. And when you do calculations that have decimals in them, what the integer does is simply drop off the decimal. It doesn't care about it. So it'll just return the 0 part of 0.75. So when you're using operators, you need to be very, very aware of this phenomenon, and you need to be hyper familiar with what certain types of integer are capable of doing or not doing. So, how do we fix this particular problem? Well, let's copy that code back over with the division inside of it, and let's modify it into a double type and another double, and make our result a double. Then let's click Go, and we get access to the full decimal number that we expect of 0.75. So doubles are fine. You could also do this with float types. Now, what about strings? It turns out you can actually add strings together. So let's define some. Let's have string name is equal to Grant. Let's have string last name is equal to Klim. Then what we can do is we can say string full name is equal to name plus last name. Then let's print this out with our console write line as full name. Feel free to change these things or the strings that you've quoted according to your own name, but once you've done that, click Go, and your console will print out your full name. Now, of course, there's generally a space between first and last names, so let's fix this little error we have. Let's copy our code from last time, paste it in. Let me create some space so we can see. And what we can do here, where we define the last name, is we can add a space in. So we can say plus, double quote, space, double quote, plus last name. So in C#, we can define a variable on the fly. We don't have to give it a name, and if we don't give it a type, C# will try and infer its type. When you put things in double quotes, C# assumes it is a string. So this is simply taking a space character and inserting it between the two names. When I click Go, we now have my name with a space in between. So those are very basic operators in C#. There's a hidden one in here that I referred to in the last lesson, and it's this equals sign. It's called an assignment operator. We're making this side, last name, equal to the right side, Klim. So that is also known as an operator. Welcome to this lecture on type conversion in C#. Let's get started right away. Open up csharppad.com and let's begin. So we've looked at variables and at operators on variables so far. What if we have a variable that we need to convert to a different type? Well, we can actually do this, but again, you should always be careful when doing this. Let's see how this works in practice. Let's have an integer called my number equal to 9. Then let's have a string called also number equal to 0. Now, even though I've called this a number, it is actually a string. So if I wanted to add these two items, I wouldn't be able to. And I'll show you what I mean by that. I'll type my num plus also num. And this C# pad will throw up our little warning triangle. So how do we get around this? Well, let's first create a var result is equal to my num plus also num. Now the also num we can convert from a string to an integer if we wish. And we use what's called the convert class. We can say to integer 16-bit, 32 or 64. Let's see what happens if we use the 16-bit version. Let's open a bracket and pop our also num into there. And that seems to compile fine. Then let's print out our console.writeLine result. Then let's click go. And we have our 9 plus 0 equals 9. Now, there's something you have to watch out for here. If I copy this code and paste it back in, and I make my string equal to Grant, which is clearly not a number, let's see what happens when I click go. We get an error. Input string was not in a correct format, i.e., you told me to convert a word to a number, and I cannot do that. Now, this gives us a nice little pretty error here, but if you try to do this in an app or any kind of software, you would get a crash. The whole thing would die. And of course, that's not a very pleasant experience for the end user. I'm going to show you how to get past these sort of errors a little later on in this section. But for now, let's look at converting some more variables in C#. Let's say I have a double my num is equal to 786. And then let's say I wanted to add this number 786 to one of my sentences. So I'd have string sentence is equal to my number is, I would close off my quotes, and then I would add my num. And if I close off that line, you'll notice we don't have an error here. And that's because sometimes C# can grab a double and infer that you want to change it to a string. Sometimes. But we're going to explicitly ask it to do this. So we're going to invoke a method called mynum.toString. With a capital T. And what this does is explicitly change this to a string. So sometimes, yes, you can rely on C# to infer what you want, but I find it's usually better if you explicitly tell it what you want. So now we can, of course, print out with our console write line our sentence. And when I hit go, my number is 786. And that's really all there is to converting variables in C#. I'm going to leave you with a warning that if you can avoid variable conversion, then definitely avoid it, because it can cause a lot of problems down the line inside of your code. So I hope you guys are enjoying this section so far on the basic C# language. This is just a little intermission to let you know about a special offer that I have for you. If you head over to learnappdevelopment.com and sign up for the email newsletter, I will provide you with a free basic C# cheat sheet that contains everything you've learned so far in this section in a handy reference guide that you can simply flick to when you want to look up arrays, conversions, or inheritance. Whatever you need is contained in this cheat sheet. It will save you hours of time trawling the internet, trying to find answers, and it will allow you to create amazing apps in much less time than it takes a regular developer. So head over there now, sign up completely free, and I will send you this guide. When we're programming, one of the more common tasks that we need to perform are comparisons. And comparisons take a look at two variables and see if they're equal, or one is greater than or less than another, or we check if another one of their properties is the same or different. Comparisons will form a core part of your programming logic. So let's see how they're done at csharppad.com. Let's create two integers to compare. Int mynum is equal to 10 and int mynum2 is equal to 20. So how do we compare these two? The first way of comparing two variables is to use an if statement. If, open brackets, mynum is equal to, and the way we define this or type this in C# is with two equal signs next to each other, and then we pass it the one we want to compare it to, which is mynum2. Then we open up a curly brace and we close a curly brace. Now, if mynum is equal to mynum2, everything between these two braces will get executed. So let's type console.writeLine numbers are equal. Then let's click go and see what happens. Well, nothing's output on our console because the numbers are not equal, so this code never gets called. Let's copy that section of code, paste it in, and let's change our numbers to both be 10. Then click go, and we get a message back saying numbers are equal because the if statement has compared them, come back with true, and allowed us to execute the code. Now again, let's paste that in, leave the numbers at 10 and 20, and we're going to play around with this if statement a little more. We can say if the numbers are equal, we'll do that. We can also add an else. And else simply says, if the if statement doesn't execute, then I would like you to execute this as a default. So inside here we can have some more code. Console write line, numbers are unequal. If we click go on this, we get the output of unequal. And that's great. Now, what if I copy all of that, I paste it in again? What if we have sort of two items that we want to check? Well, we can add an else if my num is not equal to my num2. So this is going to achieve the same thing as before, except that I can check explicitly if these two numbers are not equal to each other. And the way we define not equals is with an exclamation and an equals. And the beauty of doing it this way is that if I wished, I could have another else if that would check for something else, and we'd have whatever condition in there, and we had some more code to execute. And I can have as many of these else ifs as I wish. I can keep going and checking for program logic. So let me just remove this last one and run this. Numbers are unequal because it's gone into here, seen that they aren't equal, and returned this code. So at a very basic level, that is how you compare stuff in C#. Now you can imagine if we have 20 things to check, if else if is going to start getting a little bit unmanageable. And to solve that, we can compare things using a switch case statement. So I'm just going to reload C#pad to give us a fresh window. And let's look at how to define a switch case statement. Let's first make an integer called my num is equal to 1. Then let's define our switch. And this is going to grab my num, and then we open our curly braces, create some space, and close them. Now inside of these curly braces, we define a case for each switch. So let's have case 1, and this says if my num is equal to 1, then we are going to write console.writeLine num is 1. Then, because we've executed this case, we need what's called a break, and this stops executing the whole switch because we've found our case. Now of course we can keep testing. We can have a case where the number might be 2, and we print back 2. And so on and so on. What a switch statement does need is a default case. So if it cannot find any of these, then it will go to the default. We'll have console.writeLine, and we'll have something like, let's just say, default case. And of course we need a break with that. And then let's indent it to make it look good. So that is a switch case statement. As you can see, it's a fair bit easier to read than a whole bunch of if-else statements. And in some ways, it's a little more flexible. So let's run this, and I would expect num is 1. If I copied all of this and I changed my num to 10, we should get the default case, which we do. So those are two ways of comparing stuff in C#, the if-else statement or the switch case statement. Let's learn all about loops in C#. Loops are required in order to run an instruction multiple times until a certain condition is met. So go ahead, fire up C#pad, and let's begin. Let's begin by defining an integer called I equal to 0. This integer is going to be the counter that keeps track of how far round or how many times we've gone through our loop. The first loop we'll look at is a while loop, and this loop does things while a certain condition is or isn't met. So we have to place that condition inside of brackets. We will say while I is less than 100, open curly braces and close curly braces. Then everything we define inside of this loop will be run whilst I is less than 100. Let's have a console.writeLine and put value of I is equal to plus I dot to string. This will keep running as long as I is less than 100. So we need some way to increment I every time we go round. The first and most obvious way is to say I is equal to I plus 1. And that's perfectly legitimate. But in C#, there's a much shorter way of writing this. We simply say I plus plus, and this adds 1 to an integer. So every time the loop goes round, we add 1 to I. Let's see what happens when we click go. And we have I printed out 100 times from 0 to 99. Now, can you see a place where we could get an error? I'll show you. Back in our original code, which I'm going to copy and paste, if we had neglected to put in I++, watch what happens when I click go. It spins and spins forever. And it says my execution took way too long. And that's because the while loop kept running forever because the value of I never changed. And this is called being stuck in a loop. It's something you obviously want to avoid in your code because you cannot execute the rest of your program if you're stuck inside of one bit. With that in mind, I'll show you a better way of constructing a loop. So let's refresh this page so we have a fresh window. And this loop I'm going to show you is called a for loop. For, and then we define how many times this loop goes around by saying integer I equals 0 until I is less than 100, and then each time we go around, add 1 to I with I++. Now, I say this is better because every time you write this loop, it forces you to have a beginning, an end condition, and an operator to increase I. You could also have I minus minus, which would defeat the whole point of this. But I tend to find that having a for loop helps me avoid that endless loop problem that we have in while loops. So let's try our console.writeLine inside of this loop. I is equal to plus I dot to string. Let's click go, and there we have our values printed out. You'll also notice this is a lot shorter and more compact when we come to run our code. It also has the advantage of being able to use I again. So I'm going to copy that, I'm going to paste it in, and again, and again. Now, because these I's only belong to the for loop, they won't affect the next for loop at all. So in each of these for loops, I will always start as 0, and C# looks at them as completely different variables. If I had a while loop and I had defined my int I equals 0 outside of that, then I would have to be very careful of all of those values of I interfering with multiple while loops. So when you come to create loops, my sincere recommendation to you is to always use a for loop if you can. Arrays in C#. An array is exactly what it sounds like. It's a list of items that are all grouped together in one container. It's an array of stuff. Let's see how to create arrays and pull values out of them over on csharppad.com. First, let's create an array of strings. Let's have string and then we need to add 2 square brackets, an opening and a closing to this definition. And I've just put a space between them so it's easy for us to see. If you remove the space, it looks like a strange character. It doesn't matter. When you come to code this in something like Visual Studio, you won't have to put the space in because you'll be able to see them separately. Okay, let's call this my array is equal to a new string array. Then we open some curly braces and we feed it with some values. Let's have learn app development. Close our curly brace and put a semicolon in. Now we have defined a string array and given it 3 values. What if we want to define an integer array? Well, it's the same process. Int, open and close our square brackets, int array is equal to a new int, open and close square brackets, open your curly brace, and put in some numbers separated by commas. And we now have an integer array. Now, what if we want to grab something out of those arrays? Let's grab the app word out of our string array. Let's have string word is equal to my array, and we open a square bracket and we pass it an index of the element we want. So I'm going to pass it 1 and close my square brackets. And this 1 is going to grab app. If I had put 0, it would grab learn. If I had put 2, it would grab development. And that's because arrays are 0 indexed. So the first element is actually found at address 0. The second element is found at address 1. You always need to remember that when programming in C#, or generally in any programming language. Most arrays are 0 indexed. If you recall from our previous lessons, when we did for loops, I always started my integer I as equal to 0. And it just helps to keep that consistency throughout your C# programming code. Okay, back to arrays. We have our word pulled out of our array. Let's print it. Console.writeLine word. This should print out app. Click go, and we have our app printed out for us. Now what if we have our integer array and we want to discover how long this array is? And why would we want to do that? Well, if I tried to access element number 10 inside of this array, I would get an exception, a horrible error that crashed my program, because there is no element 10. So, it's always best to check how long our array is before we try and access something that might not be there. Integer array length is equal to our integer array dot length, and this returns an integer to tell us how many elements are in the array. Let's print it out in our console.writeLine. Array length dot to string, and click go. It tells us we have 4 elements. 1, 2, 3, 4. Now don't forget, if I wanted to access the 4th element, I would have square brackets with a 3 in it, because 0, 1, 2, 3. 3 is actually the 4th one in terms of indexing. So that's how we get the length of our array out. I'm not going to go into other kinds of arrays or lists here, but just know that C# has other ways of storing batches of variables together. One of them is list, so if you want to look that up on the web, please go ahead. The other one is enumerable. That's capital I, capital E. I'll just spell it out for you. Enumerable. Enumerable. So you feel free to go and look up that, and also feel free to go and look up list. These are other ways of storing arrays, but the basic one we have now covered. C# methods. If you recall, we've learnt how to add and subtract variables or print them out to our console. Now, wouldn't it be a pain in the you-know-what to have to rewrite that every time we had 2 numbers we want to add? Well, that's where methods come in C#. When you define a method, you define a way of handling some data that you can repeat by simply calling the name of that method. This is best seen by example. So open up your csharppad.com and let's find out what methods are all about. Let's make a method that adds 2 numbers and prints the result for us. The way we define a method in C# is by first giving it what's called an access modifier. We'll start with public. Public means that other parts of our program can see and use this method if they wish. If we wanted to hide it away, we could type private, or we could just have no access modifier. For now, let's have public. The next thing we have to define is, does a method return something? Do we expect it to give us something back? If we don't expect anything back, we have to type void. That means nothing is returning. The next thing we add is the name of the method. Add numbers. Then we open some brackets and we pass in here what are called arguments. These are simply little bits of data that the method needs in order to execute its logic. Let's pass it two numbers. Integer my num and integer other num. So this is receiving two numbers, and you separate your arguments in a method with a comma. Then open your curly brace and close your curly brace. Now all of the code in here is going to execute when this method is called. So in the method we put all of our logic. Let's have integer result is equal to my num plus other num. Then let's print it out. Console.writeLine result.toString. So this will add the numbers and print out the result. How do we call this method? Well, that is as simple as it gets. We simply say add numbers, and when we open the brackets, it requests two numbers from us, and this we have to give the method. It's not a choice. Let's give it 9 and 10. Then let's say we have another two numbers. Well, let's add some more numbers, 100 and 899. And we could do this all day with whatever numbers we pleased. Can you see the power of methods now? I can run this entire method simply by calling one line and almost even just one word. So methods avoid the need to repeat code. If you find yourself repeating code in C#, then stop typing, step back, and think about the construction of your program. Let's click go on this, and we should have 3 results printed out for us. So that is the power of methods. It really cuts down on repetitive code, and a method performs a function on some kind of data that's either passed in or available from somewhere else. Now that you're familiar with variables and methods, we have to ask a fundamental question. Where do we put them? C# in general likes you to organize your code inside of classes. So that's the first point of a class, is organization of your code. There's another point of classes that we're going to learn as we work through our examples using the site csharppad.com. So go there now and let's begin. Let's define a class. Public class, and let's give it a name, my car. Then open a curly brace and some way down close a curly brace. So this class defines something called my car. Now inside of the class we can define some properties or variables that belong to my car. We can have an integer of top speed. We can have a string of color. Now all classes in C#, for the most part, need what's called a constructor. And this is a method that fires off whenever the class is instantiated. I'll show you what instantiation is in a little bit, but for now, just know we generally need to have this method. This method is called a public, and it has no return type, but we do not type void for it. We simply say public my car. And we can pass this some arguments or data if we like. Let's pass it over integer passed top speed and a string passed color. Open our curly brace and close it. Now, let's pass over these passed in items to the class level variables. So top speed is equal to passed top speed. And what have we got here? We have color is equal to passed color. So when we instantiate this class, we will be forced to pass in these items that then get spread or assigned to top speed and color. So this class so far has 2 variables and 1 method. We can continue adding as many variables and methods as we like. So let's have a method that allows us to access the top speed of the car. Public int. And when we type int, we're implying that when we call this method, we're going to pass back a result which will be in the form of an integer. Get top speed. Open and close brackets because we're not passing any data. Open your curly brace and close it. So what are we going to pass back in integer form? Well, we want to give back this top speed. And you may ask, why don't we just simply go here and grab the top speed? Well, that's kind of a bad thing to do in C#, because if you simply access this straight away, anybody else that's working on the same program might do the same thing. And one of you will modify this, the other will modify it to what they want, and in the end you get what's called spaghetti code. No one knows who's doing what. So you can think of methods like this as public channels that you must use in order to access variables in your class. You should never access variables directly. So in getTopSpeed, we are going to return the top speed. Now let's have another method. Let's have a public void paint car. And this is going to pass over a string with a lowercase s called new color. And this string we're going to use to paint our car. So color is equal to new color. Whoops, I just tried to save it there, but it's a web page. I always forget that. Okay. Now I'm just going to copy this class because we're going to reuse it a little later. But just looking at this, we have now defined a class that holds the blueprints, if you will, for something called my car. Now, the word blueprint here is very, very important That is basically the main function of a class. It's a blueprint that holds instructions that relate to creating a kind of object. So this one has the blueprints for a car. The car has a top speed, it has a color, you can get its top speed, and you can paint the car. And this is something that you could apply to any car that you see on the street outside your window right now. So a class in and of itself doesn't actually do anything. What we have to do is called instantiate a class. And this is just a big fancy word that means we're going to make an object using that blueprint. So this object is a variable in a way, like we've already experienced strings and integers. This variable, however, has a type of my car. So let's type my car Toyota is equal to a new my car. And when we open up this bracket, it goes over to that public my car and asks you for some top speeds and colors. So let's pass it 89 and a color, red. Now we have created a new car called Toyota. Let's print out the top speed of this Toyota. Console.writeLine Toyota dot, and now these methods that we defined earlier become available to us. Get top speed. And let's convert that to a string inside of our console write line. So this is going to open up a new object based on the blueprint of my car. It's going to be called Toyota. It'll assign a top speed of 89 and a color of red, and then print out that top speed to us, but it's going to access the top speed using this access method here. So let's click go, and hopefully that all works out. And it has. Now, what if we wanted to paint our car a different color? Well, let's copy all of this again. And let's paste it. So we have our car class. We have Toyota, which is red. And then underneath that, in our console write line, let's paint our car. So Toyota dot paint car, and this asks us for a color. Let's have green. Now, when I run this, our car color will change to green, but we don't know because we haven't printed out anything to the console. So that is the basic idea of classes. They hold blueprints that allow us to define new kinds of objects. Classes are one of the fundamental concepts of object-oriented programming. Now, you may have heard that term before, but this is where it fundamentally comes from. We have blueprints, and we create items from those blueprints, and those items are generally called objects. I could have a Toyota object, a Ferrari one, a Nissan one, whatever we liked. So object-oriented programming always thinks about the objects and not really about the classes. The classes do their thing, but we always focus on the Toyota that we made or the Ferrari that we made from that class. Inheritance in C#. Again, this is one of those fundamental cornerstones you really have to know when you start programming. Inheritance allows us to write much less code and for our classes to inherit a bunch of properties and methods that we can expand upon. So let's find out what this is all about by opening up C#pad.com. Let's define a class. And let's call this class vehicle. Public class vehicle. Let's give it some properties of integer top speed and integer, or not integer, let's have a string of color. Then let's put an access method in there to grab out our top speed and color. So public integer get top speed, and let's return our top speed. Then let's have a public string get color, and of course we're going to return our color. Finally, we need a constructor. So public vehicle, and we will just have an empty constructor for this. Okay, so we have our vehicle. What if we wanted to make a truck class? Well, if you're thinking linearly, I can't even say that word, linearly, then you might copy all of this and create a new class called truck. But that would be the long way of doing things, still valid, but nonetheless the long way. What we can do is create a class that inherits from vehicle. Public class truck, put a colon in, and start typing vehicle. Now this class I'm going to leave completely empty. Then what we're going to do is actually, before we carry on, I'm going to set my top speed in vehicle equal to 90 and my color equal to red, just so we've got some variables to play with. Okay, so we've created our truck that inherits from vehicle. You'll notice I've put no code whatsoever in here. Let's see what happens, and I'll just make a little space for us, when I type truck. My truck is equal to a new truck, and close off my line. Now what I'm going to do is console.writeLine my truck. I'm going to grab this truck I've just created, dot, and you'll notice it gives me get top speed and get color. So we'll print out our color. So what inheritance does is it grabs a class and basically steals everything from it and repurposes it for itself. So if I run that, we have a truck that has a color of red. And that is inheritance. Inheritance is incredibly powerful. So if you think about inheritance like evolution, we all came from some kind of single-cell organism. So that organism has, let's say, a property of cell. and we all have cells, no matter what species. So we inherited that cell's properties as we went down through the tree of life. Now, inheritance can be used multiple times. So if I copy these lines, and in fact I reload the page to make everything a little more clear, I'm going to paste them in, and what I'm going to do is remove the get speed and remove the top speed. I'm going to leave everything else in there, but just smash it all together so we have a little more room to see what's going on. So I have my public class of truck. Now, what if I wanted to create some property inside of truck called string size is equal to large? Well, I could create another class, public class large truck, and this would inherit from truck. And again, I don't have to put anything inside of here. Then I could say large truck, my new truck is equal to a new large truck. Then let's do our console.writeLine, my new truck dot, and what we need is to get the size. So inside of this public class truck, let's have public string get size, and of course we will return the size. Don't worry if I'm going a little fast right now. I'm going to explain it all in a minute. And then in our console.writeLine, myTruck.get size. And that should compile, but that's because I've put a colon rather than a semicolon at the end there. Okay, so what's going on here? Well, we've defined a vehicle with a color. Then we defined a truck, and we added an extra property called large. And then we defined a class called large truck, which simply inherited from truck, which inherited from vehicle. So what I'm trying to show you here is we can inherit multiple times. Vehicle to truck to large truck. And when we do that, we pick up all of the properties and methods along the way, such that I can create my new truck and I have access to all of those properties and methods. And if I click go, it'll return the size, which is large. C# exceptions. This doesn't mean probably what you think it means. I'm not going to talk about exceptions in C# as the English language defines it. Exceptions are occurrences that take place in our app when the code does something that C# or .NET rather doesn't expect to happen. And what happens is it throws an exception, which is basically an error. And this error doesn't just confine itself to its own space, it takes down the whole application with it. So obviously, this is something we need to be acutely aware of. We also need to know how to deal with it. Open up your C#pad.com and let's find out how to deal with these pesky little exceptions. Let's start by defining a string called myName is equal to Grant. Now let's try and convert that to an integer. Integer mynum is equal to convert to int16 my name. And can you see what's going to happen here? Well, you cannot convert a word to a number. So when I click go, we are going to get input string was not in a correct format. That's a nice error. However, in an app or any kind of software, that error would crash the entire program. These errors do not confine themselves to their own little space. They like to take down the whole system with them. So, there are two ways of handling these errors. Number one, don't do it in the first place. Do not convert something like a string with a name in it to a number. Don't do it unless you really, really have to. So the best cure in this case is prevention. However, there are times when you will have to run code that could fail. So let's look at the solution for that. I'm going to paste this code back in. What we can do is surround the line that you expect to fail with something called a try-catch statement. So we surround the line that we're interested in with try. We open and close some curly braces to surround it. And then we type catch, open brackets, exception E, open and close curly braces. Now, anything that gets attempted inside of try, if it fails, the error or the exception is passed over to catch, and we can execute a bit of code based on the assumption that something has failed. So inside of our catch statement, let's send ourselves a developer message, console write line, called error. And then let's add on the exception message, which is contained in e.message. So let's click go. This is going to fail again, but we'll pass ourselves over a message. Input string was not in a correct format. Now in this second case, our app will not crash. We just get a message back as the developer. If you are going to present this to a user as a message, you would never say e.message, because input string not correct format is very confusing for an end user. You would say, hey man, you put your name in when you should have put your age. That's a bit silly, isn't it? You would give them a message that they can understand. So that's the basics of exceptions in C#. An exception is basically an error, and that is something that you can catch inside of a try-catch statement when you expect a high likelihood of an error to take place. Congratulations, you have finished this section on C# basics. You now have all the tools you need to program basic C# programs and to understand more complicated concepts. You've learnt all about variables, operators, conversions, comparisons between variables, and loops that allow you to run code over and over again until a certain condition is met. You've also learned about arrays, which are lists of data, methods that prescribe certain ways of dealing with data or manipulating variables, classes that are a fundamental building block of object-oriented programming, along with inheritance, another fundamental building block. You also learnt about exceptions, which is a fancy name for errors, and how to deal with them inside of your programs. So well done once again for completing this section.